Time series models. Okay, what is a time series? A time series is simply a list of any value, okay, over time with consistent periodicity. Okay, for example, if it is daily sales that you're talking about, then you must have a value for each day of the week. Okay, if it is monthly sales, then you must have values for each month without any break. So continuous time and equal time intervals. So you can't have like one observation is sales per week and the second observation sales per month. So if it is weekly, then each and every observation in the list must be per week. If it is daily, everything must be daily. If it is annual, yearly, then everything must be yearly, and so on. So the past historical record of just one variable without any break with consistent time intervals. Now, once you have that data, then you can plot that data and then see what kind of pattern there is and extend that pattern into the future. And that's basically the principle behind it. So it ignores all other factors that may have an impact on sales. It only looks at what the fluctuations are, and the idea is that all of these other factors that we're ignoring, they are the ones that are actually causing the ups and downs. So ignoring those factors really doesn't mean that we're completely being, randomly selecting our forecast, but we are looking at the impact of these factors that we are not directly taking into account, and that impact is showing up as the ups and downs in the time series, and we are trying to use that effect of these factors that we seem to be ignoring, okay, in our consideration for forecasts. Time series can be thought of as having 4 components, okay, of which the random component will always be present. Okay. The other 3 may or may not be present. Okay, trend, seasonal, cyclical, and random. Okay. Now, if there is no random fluctuations at all, then there is the forecasting becomes trivial because you know exactly what's going to happen. There is no randomness. You'll be able to calculate the exact answer for forecasting. But that's not how things work. So you will always have random fluctuations. Now, what about these 3, trend, seasonal, and cyclical? What are they? Let's look at examples of time series. So here is a time series plot. So now we have periods on the x-axis, so time periods, quarters, and then we have sales on the y-axis. Okay, and think of this as 4 different panels. I don't like the way they have presented this. So this first panel, okay, so we plot the y values, the sales values over time, and you see there is random fluctuations going up and down, but it is going up and down around a central mean, if you will. Okay, it's fluctuating around that mean. So here there is only random fluctuations, nothing else in series 1. Okay, there is no trend or seasonality, it's just random fluctuations. Now here you see there is a predictable pattern of going up and down. So 1, 2, 3, 4, and the same pattern repeats, not exactly the same, but slightly different because of the random fluctuations that may be present. So it goes up. So it goes up and down in the same sequence, same ups and same downs. Those are seasonality. Okay, there is no trend. Okay, there is only seasonality and random variation. Okay. Now here we have trend. Trend is long-term gradual increase in the average value. So the average value in this first panel stays the same. But here the average value is slowly showing an upward trend. And there is random fluctuation still present. Okay. But the mean value is not flat, not horizontal. It shows a gradual increase. So that's called trend. Trend is long-term gradual increase in the average value. Now here when all four are present: trend, seasonality, well, all three: trend, seasonality, and random fluctuation. So we have the trend going up, and then you have the seasonal pattern, and then there is randomness. So all three are present here. Okay, now what about this cyclical variation, the fourth variation? Cyclical variation is long-term ups and downs. So in seasonal variation, there are two basic differences between seasonal and cyclical. Seasonal is ups and downs. Cyclical is also ups and downs, right? So they both are sound same, but the two differences are you don't know how long the ups and downs will last. Okay. In seasonality, you know exactly what pattern there will be. So it goes up in fall every year. It goes up in fall. It goes down in winter, then it goes down in winter every year. Okay. So that predictability in whether it's going to go up or down, okay, is not there in cyclical. It may go up or down. Okay. And the length is the second factor. So in seasonality, the length of the season is very well understood. So if it is quarterly season, you know there is 3 months to one season, 3 months to the next season, 3 months to the next season, and so on. Whereas in cyclical variation, how long a particular up or how long a particular down will last is unpredictable. Okay, think of it as economic ups and downs, recession or growth period. Okay, how long a recession will last, we don't know, but we will ultimately come out of recession and start growing. So here is cyclical variability in a graphical format, a time series format. So here we have time in years. Okay, so there are ups and downs. Okay, so here is one down, and then there is up. Okay, here is another down. So this time period and this time period need not be the same. It could be quite different. So that's cyclical. Now, when it comes to modeling time series data and trying to figure out forecasts, we'll see that it is the approach that we will be taking is averaging the random fluctuations out and then trying to project into the future. So we can pretty much handle all of these cases. If you have just random fluctuations, we can average them out. If you have seasonal variation with randomness, then we can average the randomness out and we can try to understand what the seasonal factors are. If you have trend, we can again predict what the trend will be and try to project that trend. And if you have both trend and seasonality, we can do both. You can try to predict the trend, we can try to predict the seasonal variations and extend it out to the future. But when it comes to cyclical, there is, because of the uncertainty with respect to how long it will last and whether, when is the up and when is the down coming. So it's very hard to really analyze these and use it for prediction. You can analyze it and see how weak or how strong the ups and downs are, but it is not possible to use them in forecasting. So we'll only be looking at trend, seasonality, and just randomness in our analysis. We will ignore cyclical variation when it comes to forecasting. And in time series models, there are two basic models that we can think of. One is multiplicative, where you take each component and multiply them out. So except for trend, the rest of them will be like factors. Whereas in additive model, you add them out. So this will be actual, the amount of seasonality, the amount of cyclicality, the amount of randomness when you add them up.